So you've taken care of PFAS with thermal remediation in the lab. How did you bring it out to the field?
Oh, that's a very good question, and I would say we are in the process of bringing it to the field. What we've done, we've probably done more than any thermal vendor, is high temperature treatment. So we've completed over 20 different projects where we've heated the soil to temperatures in the 200, 300, 350 degrees C range. So what we're looking at with PFAS is using the same type of approach. But some of the questions with PFAS are different. As opposed to, one or two chemicals, we have thousands of compounds that we're potentially treating or heating and treating. We can't analyze for all these compounds, but we can track the fluorine associated with our mass of PFAS that's in the soil. So we know how much fluorine or PFAS we have. It could be PFOA, PFAS, a whole range of stuff. But we know how much PFAS we have in the soil because we can measure the total fluorine. So what we wanted to do was to look at where that mass goes. What is the fate of it? Does it just magically disappear in the soil, or does it volatilize? And if it volatilizes, then we have an issue, or now we have a challenge to effectively treat it in the vapor treatment system. So what we were able to find in our lab studies is that we get roughly 40-45% mineralization, breakdown of the PFAS compounds and mineralization and formation of things like metal fluorides in the soil that are bound in the soil. And the question is, what happens to the other 50%? Well, that turns out it volatilizes. So we don't know, we don't have a crystal ball and detailed look at this. But what we think is that we're getting some degradation, decomposition products that are more volatile than the parent compounds. And those are getting volatilized and removed from the soil. So what we're looking at, what we did most recently in our lab studies, was to evaluate the use of high temperature catalysts for the further breakdown of these species coming off of our soil. And that was really encouraging. We completed that this summer. What we're able to find is that using specific catalysts and formulations of catalysts and at specific temperatures, we can get near 100% mineralization of the PFAS compounds within our soil, combined with our catalysts that we're using to treat the vapor stream. So we're looking at non-detect or really close to detection limit emissions coming out of this.